If we turn toward a more realistic problem of compounding, let's look at the end of the month when the numbers are getting a little more stable. They're not so small, which allows for huge variations because of accidents. They're they're larger. We can make some kind of prediction. We see, let's consider what we would make of the last week of March. If today was the 24th of March and we were looking forward to 1 week until the last day of the month, what could we predict? We know the actual number, and it's nearly 4 times larger, so it's not an easy thing to predict such a big change, or what is in context a large gap of time. But still, we have a better chance of doing something accurate. And the point really is not to get the numbers spot on, not to predict exactly what will happen, but to have some measure of what the meaning of the change is. This time is just about when the government is changing the rules, putting the stay-at-home orders in place. And we would like to know whether those are having any positive effect, whether things are still getting worse, and even worse, whether there's no change, or whether there's a slight improvement. And the slight improvements, especially in highly emotional situations like this, when one's friends and neighbors are dying, the slight improvements are hard to get your mind around. If the disaster imposes on your experience, if you have, if the human value of what we're actually counting is part of your life, then you're bound to take it seriously and maybe exaggerate it. And if it seems distant and something abstract and happening only to strangers, you're about to undercount it. And there are a million differences of experience and personality that make for different reactions. And the numbers do not cure those problems. They don't give us something absolutely solid and reasonable that we can count on absolutely. But they do help to give our choices some better grounding in what's actually happening. So if we look at this problem, imagine that it's the 24th of March, and we're trying to predict what will happen a week later at the end of the month. We can do the simple arithmetic that calculates an uncompounded rate. With modern calculators, it's easy to translate that into a rate for continual compounding. We can put this in our formula. We take the rate multiplied by 7 days and make that a power of e, and then multiply it by the concrete number we have for the 24th, and we get this prediction, which is still considerably off. It's about 1/3 higher than the number that we actually get. More useful than the very small number we got before when we were looking at the first couple days. 6 times too low. And the very large number up in the millions rather than the 100,000s we got when we were looking a few days later is much more useful, but still off. And yet we can say that there's some sense to treating that number of 240-some thousand as an accurate prediction, not simply close enough, but a representation of what was happening actually on the 24th. Because if we see, where did the 185,000 number come from? It came from a time of improvement. That the number of cases was going up by more than a quarter on the 25th, and a little less for the next few days until it was more like 1/6 than 1/4. And if you compare that to the deaths over this period, we'd say that if our prediction had come true, there would have been something over 1,000 more deaths. So that would be than we actually got based on the cases that we ended up having. So that would be the start of making an argument that the stay-at-home orders actually worked, which then using numbers to ground that argument, to make that argument reasonable and more persuasive. And that is, of course, your assignment for next Sunday.